So let's start looking at each of the different types of services offered by the cloud providers. First up is infrastructure as a service, or IaaS, right? So here the examples would be the likes of virtual machines, storage options like local disks, both HDDs and SDDs, remote disks like virtual disks, network attached storages. Those are all options available to you. Memory of different sizes, 16 GB RAM, 128 GB RAM, doesn't matter the size, like doesn't matter the manufacturer. CPUs versus GPUs, like so many options available here. Network types like 1 gigabit Ethernet, 10 gigabit Ethernet, or like some other types of networking technologies like banyan tree topologies, etc., etc. Operating system flavors, Linux, Windows, Mac, etc., etc. So all of these are typically associated with infrastructure as a service options available. As you can imagine, all of these are at the cloud layer. Nothing to do with the software, nothing to do with non-functional or functional sites. It's just purely at the cloud layer. As a software designer, you would just need these things to be ready in order to run your software if you own the entire software together, right? So, what are the advantages of something like this? It gives you, as a user, maximum control from a software perspective. Again, I'm keeping in mind you as a software designer, somebody who designs software using cloud native principles, right? So, if you used infrastructure as a service options, you get maximum control because you get to choose every single thing related to what type of infrastructure, right? Like VMs, memories, CPUs, GPUs, etc. But on the flip side, in order to control, you need to have people who know how to control, right? Which are usually the IT administrators. So that's the negative side. Now, I just want to make one definition clear. Virtual machine corresponds to a machine which is actually not a physical machine, but it's virtual. As the name suggests, a virtual machine is usually doesn't exist physically. In reality, it is a combination of physical resources being earmarked or isolated for a specific virtual purpose. Virtual here refers to the fact that it gives you the impression as though it's a physical resource, but it is only a virtual construct, it's only an abstraction, right? So, in practice, a physical machine will have multiple different virtual machines, which have been mutually exclusively earmarked and isolated from within the pool of resources available in that machine. So, if you take a physical machine which has, let's say, 16 CPUs and 64 GB RAM, and you could construct, and you wanted to construct machines of virtual machines of smaller size, you could do it as 4 virtual machines, each uniformly having 4 CPUs and 16 GB RAM. So that way, in total, they total up to 16 CPUs and 64 GB RAM, right? So that kind of a setup, those 4 virtual machines will be made to look as though they are 4 standalone machines with standalone IP addresses and standalone addresses and referenceability, and the cluster would look as though it has 4 machines, but in reality they are all 4 virtual machines sitting on the same physical machine. Alright, and remember that we spoke about the separation of storage from compute. So infrastructure as a service options from public cloud naturally support this, right? Storage options are separate. The virtual machines are usually metered based on CPU and memory only, right? Very rarely are they metered based on storage, because they are fundamentally separating out these two concerns altogether. Okay, so for what kind of software patterns is infrastructure as a service suitable for? One of the common patterns is whenever you have open source software as part of your setup, right? You typically want to have complete control on the hardware on which the open source software operates on. The reason being, open source software is fundamentally built with the philosophy of complete flexibility and control, which means it rarely takes a position which is preferentially giving biased treatment towards a certain infrastructure. So in that kind of a setup, usually what happens is the company that you work in or the problem statement that you're solving for, if it uses open source heavily, it's quite likely that it also needs control. It also needs the infrastructure as a service options. So it's suitable for those kinds of companies which are developer heavy, meaning dev shops, that do not want lock-in of other kinds of approaches which we'll talk about later, right? Meaning wants complete control, because the opposite of complete control is loss of control, right? Which is what happens in when you feel locked into a specific choice of technology or a specific choice of hardware. You don't have control, and therefore you feel suffocated, right? You feel that you're not able to scale, you don't have the capabilities or the properties that you want. Now, that is typically true for companies which have a very large developer talent, which is mainly the MNCs, the large funded companies, the SaaS software companies, and those kinds of setups, right? They want this complete control on the ecosystem on which they operate. Now, to truly do the kind of work that IT admins need to do in this infrastructure as a service setup, nowadays there are very good software technologies that have evolved, right? These software technologies make the act of administering and managing and maintaining the infrastructure components much more easier than having to manually go and manage these. So those fall under the realm of software called as IT automation software. They allow you to almost reach the level of benefits that platform as a service components provide to you. Right? Examples of these kinds of software are Terraform, Ansible. These are all open source, right? Available for you to easily use in your setup. Now, let's take a look at the next category of services provided by the cloud vendors. This is called as platform as a service, or colloquially referred to as PaaS. Now, in the world of PaaS, you start to get towards the non-functional aspects of software. So, imagine you're building a big application. The application is trying to solve for a business problem statement. Then some parts of that non-functional capabilities that you need will start to get solved if you start to use PaaS options that cloud providers provide. What are some service options in PaaS? Examples would be databases, application execution environments. I'll talk about that in a minute. Container service options available on the cloud providers. Workload specific execution environments, not general purpose applications, but workload specific. So let's break it down further. Databases refers to the RDBMSs that we spoke about before. Those can be offered natively by the cloud providers as a service where you don't have to worry about configuring virtual machines and then installing a database software, then configuring the database software for your needs, worrying about how the database software works under fault tolerance guarantees, how does performance operate, how does the database perform under loads, how do you tweak that, how do you change that, how do you cater to variety of different types of workloads that operate on top of the database, be it long-running SQL queries or be it very quickly executing transactional processing. All of that is abstracted away from you, so that you don't have to worry about that level of configurability, right? You just operate at the database level of abstraction, which means to the database you say, look, I want to be able to operate 1,000 transactions per second. Look, I want to be able to store 1 terabyte of data with you. Look, I want to be able to do 100,000 IO operations every minute, right? That's the unit of metering. That's the unit at which you tell the database to configure itself. And the database figures out what machine it needs behind the scenes, what cluster that is need behind the scenes, right? How does it deal with performance? How does it deal with fault tolerance, with resilience? How does it deal with backups, with with the ability to recover after a disaster, like a natural disaster, like an earthquake that affects its data center, right? All those kinds of things are taken care of for you automatically. That's in the world of database as a service. Application execution environments give you the guarantee that you can operate an entire application without having to worry about, again, virtual machines, CPUs, GPUs, network, disks, or anything like that. So here you could say, look, I want to run this kind of an application. You give me the ability to manage VMs and networking and software so that I don't have to do any of that management myself, right? So those are what's called as application execution environments. So in the world of Amazon, there's an example called as Beanstalk. Beanstalk is a great way to program applications. That would be a good example, right? It's a good way to create applications, mainly meant for very opinionated, small-scale applications that you can easily take to market. It's kind of restrictive because it doesn't give you all the gamut of flexibility and features that you would get with a general-purpose container service. I'll talk about that now, right? A container service is basically a service that allows you to run containers, and these are software containers, right? Containers which are running software which have been built using cloud native design principles to operate at a unit of execution being a container, as opposed to being a hypervisor, right, or being like a virtual machine, right? So in this kind of a model, the container is lightweight. The container has the ability to operate on any kind of virtual machine behind the scenes, right? Any kind of hypervisor behind the scenes, and the container abstracts away the file system, the network and storage and CPU for you, right? So the container service basically gives you the ability to spin up copies of your application across multiple different containers running on multiple different virtual machines, running on multiple different physical machines, such that you can get the scale that you need without having to worry about manually monitoring or managing or observing it, right? Manually maintaining it. None of that is necessary. The container service automatically scales up to cater to the increased demand, and also automatically scales down based on whether the current demand has come down or not, right? So one of the most common examples of this is what's called as Kubernetes, spelled as Kubernetes. You can search for it online. Kubernetes is a service which is becoming extremely popular as a container service, and it's very portable across multiple different cloud providers. Then the next up, we have workload-specific execution environments. So here, the critical part that we need to keep in mind is these are like container service execution environments, but very specifically designed for specific types of workloads, not general purpose workloads. So if you take a look at big data as an example, big data itself is a combination of, like we mentioned, multiple different types of technologies. Like let's take Spark as an example, right? So there are Spark execution environments available as a service on all the cloud providers, and you can use them as though you use them without having to worry about the underlying CPUs, memory, disk, and so on. And those become Spark PaaS options, right? So the example here is EMR. Elastic MapReduce is basically able to run both MapReduce and Spark on top of Amazon without you having to worry about managing networking or hardware or memory, etc. Likewise, Databricks, likewise HT Insights, etc., right? So a lot of options available for you when you start to look at workload-specific execution environments. So in a nutshell, if you look at advantages and disadvantages, for a PaaS kind of a service option, the cloud provider actively manages the underlying infrastructure for you so that you can focus on what is necessary for the business to consume, for the business to scale faster, right? So it's ideally meant for developers who are not IT admins, but who know what to do with functional pieces of software so that they can allow for scaling of the business easily. But in return, what this means is you have lesser control on the infrastructure. You don't know when the fault tolerance will kick in. You don't know when the backups will happen. You can only configure it, you can't customize it. And what also happens in reality is that some of the PaaS options that these cloud providers provide are not really as mature as the infrastructure as a service providers, as the infrastructure as a service options, right? So which means it's less stable. Sometimes the documentation is not up to speed, but those are practical problems, right? In the long run, obviously, all of this will get solved for. And sometimes it's also about predictability, because in practice, you'll see that a database which is managed by a cloud vendor has its own patching cycles, right? Which means that the vendor decides when the next version of MySQL will get rolled out into production, and sometimes they may not tell you because they're managing the service for you. They have complete control, and their communication to you as a user might not be up to speed or might not be up to mark. In which case, they might change the software behind the scenes and not tell you, and maybe some of your application might get broken. So that results in loss of predictability. Can happen, and it happens in practice, right? We've all known that. Alright, so what are the software patterns for which PaaS is highly suited for? The first and foremost is, if you want to write software which is purely focused on the business, but you want the ability to auto scale as the underlying workloads change, as the customers sign up more and more, as the volume grows, then PaaS is a great option. You don't have to worry about the administrative complexity. You've written it in a way that's cloud native. The complete non-functional aspects of it are taken care of for you, which allows you auto scaling capability, both up and down, mind you, right? Example, Indian Railways again, right? Festive season like the Diwali or the New Year, the ticket sales just rise up rapidly. So you want your ticket processing system to operate at 100 times the capacity that it would normally do. But once the season is over, you want to come back to 100th the size, right? So that ability to auto scale up and down, and sometimes even auto scale up and down intraday, during the day versus the night, etc. All of that is a critical capability. So if you have that kind of a need, PaaS just takes care of things like this automatically for you. Super, super helpful, right? The second thing is that, like I mentioned in the world of databases, even for containers, those service execution environments automatically take care of things like availability, automatically take care of things like, spinning up a new environment in case the primary environment gets affected due to natural disasters. They take care of things like backups, they take care of things like recoveries and things like that, right? So that's, again, fault tolerance, this high availability fault tolerance is, baked in to the PaaS options, super beneficial. Yeah. Then the third angle here is, let's say you want to start a brand new exercise. Like what I mean by that is, you want to start a new startup, you want to start a new application, and that application for the first time starts off with certain kinds of workloads. But then as you progress, as newer workloads come in, or as the client base increases, you want the ability to spin up newer machines, right? Newer hardware, which will cater to these newer workloads much faster. In that kind of a setup, the PaaS options give you the ability to do what's called as a readily executable environment in which to run that workload. In a pure infrastructure as a setup option, in contrast, you would need to get the virtual machine, you would need to get the software installed, you would need to certify it, you would need to test that it works correctly, and then you would need to run it for whatever workload that you want. Whereas in the PaaS setup, all of this becomes a ready image or a ready option that's already tested and serviced and proven. So you can do what's called as on-demand provisioning and completely cut down on the latency associated with what's called as bootstrapping that particular workload. So that's very helpful in certain kinds of mission critical workloads. Then the fourth part which you need to be worried about, or which you need to take into consideration, is for PaaS heavy workloads, you have to worry about where you maintain data and where you maintain that state associated with that application. Because unlike the computation, which can be easily scaled up or down, data is a critical state. Rather, data and state, application state will require their own fault tolerance principles, right? What if the primary database fails? What if the application state is in temporary storage like memory, and if that machine fails? So you'll have to think about those angles a little bit more carefully. So with that, I'll stop here. I'll talk about serverless and what big data and cloud do together in the next video.